Hello, everyone, and welcome to another edition of Let's Talk ETC. I have a previous guest with me, Vaibhav Saini of Towards Blockchain. You may recall that he previously enlightened us about IPFS, the Interplanetary File System, and he's also written an article on private blockchains. You may know about Quorum, which is a private Ethereum Classic-like system. And so a lot of people are confused about that. So I thought I would invite Vaibhav on again to explain why the details, why anybody would care, all the issues surrounding private blockchain. So welcome again, Vaibhav.
Yeah, thanks for the introduction. Glad to be back here.
Give people a little bit of your background.
Yeah,
It was impressive.
sure. Yeah. So I started my blockchain journey in mid 2017. Like most of the people, I started by trading coins, and I traded Ethereum, Neo, IOTA, Bitcoin, and other stuff. I'm also super interested by startups, so I was working with a few, but those startups were not super interesting for me. So I started my own startup. So in December 2017, I dropped out of my college, IIT Delhi, and started my own startup towards blockchain with a bunch of guys from organizations like Google, Tesla, and MIT. Since the start, I was a technical lead there. I studied a lot about distributed systems, consensus algorithms. I wrote a bunch of articles on consensus algorithms, smart contracts, some of which got a bit viral. I also worked on private blockchain systems like Quorum and tested it and published our findings and articles. I'm also heavily involved in IPFS, and I also manage a lot of open source projects under the umbrella called Cluster Labs.
Okay, good. Now, for the people that are interested in Towards Blockchain, how would you describe it in one or two sentences? What the mission or the purpose of Towards Blockchain is?
So, describing Towards Blockchain in one line, we actually tend to provide real world blockchain applications to the world, because there's a lot of since 2017 there are a lot of blockchain companies coming in, but like they didn't deliver according to their promises. We don't tend to do that, and we actually want to give some actual real world use case applications using blockchain.
Okay, so an application developer. Okay.
Yeah, good. Basically in the field of identity.
Okay, good. And then and also, of course, you write a lot of articles, so you're an educator as well. Yeah. Okay, good. So let's now switch to what we're all doing here now. So would you please enlighten us on why in the world anybody would use a private blockchain instead of just a traditional database? That's the question everybody always asks.
Okay. First start, you can say that the private or permission blockchains are just customized databases which have some additional features which makes them auditable and verifiable out of the box. Blockchain is actually a database because it is a digital ledger that stores information in form of blocks, whereas a traditional database stores information in form of tables. One of the major advantages that I see in that blockchains use cryptography in its very building blocks. One of the major examples it uses cryptography is in form of hashes. This is what makes blockchains immutable. We can take a transaction and put it in a hash function, and then it will give me a unique output. Now, this output has two main properties. First, it is one-way function, which means that if I put my name as input and in the hashing function and it will give you an output, you cannot figure out what the input was. It's really a computationally very hard problem to solve. The second main property is that it's very easy to verify. If I give you my name and the hash of it, you can easily use the hashing function to verify that I didn't give you my fake name. These basic properties, along with additional features such as smart contracts, make blockchains more secure, verifiable, and auditable than traditional databases.
Oh, okay. So I've heard other people say that private blockchains are great for auditing.
Yeah,
So is the concern with a traditional database that people could it's too easy to change the tables and hide transactions?
yeah,
Okay,
yeah,
whereas with
yeah,
blockchain,
exactly.
okay, so you would, to compete with private blockchains, you would have to somehow make a database that was write only, like that, like a
Yeah,
GitHub
yeah,
repo that never lost any history.
yeah, yeah, sure.
Okay, all right, that makes sense. And so, what is the security like? Now, they don't have proof of work. There is actors that have some degree of control and can even roll back transactions, if I'm not mistaken. So, what do people need to be thinking about regarding the security?
Okay. Every system or a network needs to establish trust between participating members. Now, there are different ways to bootstrap trust. In the case of Bitcoin, which is a public blockchain setup using proof of work, we don't know anyone in the system. All I see is the public addresses. So no one is going to trust each other based on their identity. So you have to come up with a way using which you can bootstrap trust. In Bitcoin, we make it hard for people to cheat each other. Here, in order to cheat someone, I have to cheat at least more than 50% of the participating people. So if there are million people in the Bitcoin network, so I have to cheat at least 500,000 people. So this,
Are you talking about for a 51% attack?
yeah, yeah,
I don't know if you need to cheat some number of people, but you need enough hardware to compete.
yeah. Basically, yeah. Like I'm abstracting that only.
Okay.
Okay. So this property of making it hard to cheat or using this computational power establishes the trust to make the system usable. Now coming to the private and permission blockchains, here we usually don't uh, allow anybody to join and start participating in the network. We only allow people who pass some specific requirements. So, like in case of Hyperledger Sawtooth, which is a permission blockchain, we use a consensus algorithm called proof of elapsed time. The way it works is that only people who use a specialized hardware can participate in the system. This specialized hardware follows the rules of the network to perform the actions. So if all the people in the network follow these rules using this hardware, then we can actually trust the system. Another way to secure the private networks is to harness the fact that we know something about the identity of the people who are joining the network. So if anybody messes up, his reputation will be damaged. There are tons of variations of these types of consensus algorithms which use repetition aspect of the participants to bootstrap trust in the system. By the way, I wrote an article about 30 plus consensus algorithms. Anybody who wants to know more about these variations can just search on Google for list of consensus algorithms. It's the first page on article on the page. This article was cited by one of the Princeton University courses.
Okay. Okay. Now, so you mentioned the security, how it can be dependent on reputation and special hardware. Now, I threw out the idea that they might be able to roll back transactions, but I don't really know. Presumably, for auditing purposes, maybe you'd want to set it up so that you couldn't roll back transactions. But are you aware if that happens ever or commonly?
Yeah, so basically, you can roll back transitions in a private blockchain, but like that can be only be done with only the people who have actually the permission to do that. In case of databases, like the hacking is easier than blockchains because it doesn't uses the cryptography out of the box.
Okay, but I mean, doesn't that violate the goal of being easy to audit if you allow people to remove transactions?
Yeah, so it like it's a two-way thing, because sometimes you mess up some transaction and you have to revert that. So in that case, you can, yeah, it actually benefits the users. But when it comes to auditability, if someone who is not allowed to revert a transaction, it can actually hamper the auditability
Yeah.
part of the
Okay. Or okay. All right. Makes sense. So maybe they could somehow do it so that the fact that it was reversed is still written on the private blockchain.
yeah. So
Something like
basically, you append to the blockchain, not actually delete it.
right. That I could see how that would have it both ways. That would please the auditors, but still allow you to roll back transactions. Okay, that makes sense. And also, I've seen some videos for some different private blockchains, and they allow private transactions between members of the private blockchain system. So how does that benefit from blockchain? I guess the one answer is it benefits because it's still auditable. Is there any other benefits to having private transactions between two parties on a private blockchain?
Okay, we can take an example. When we do a private transaction, only the people involved in the transaction know about it, right?
Mm-hmm.
So let's suppose we are using a traditional database. Now, if something messes up in the transaction, and one of the participants has to prove that other participant did something wrong, I cannot prove that without revealing the details of the transaction. That damages the very privacy of the transaction. Now, let's suppose that we are using a blockchain. Then we have methods like zero knowledge proofs, which can cryptographically prove the validity of the transaction without revealing the details of it. So basically, you can say that the cryptography gives some advantages to the blockchain with respect to databases.
Okay. So there is benefits to having even private transactions on a private database. Okay. Yeah. And yes, I could see how zero knowledge proofs would be useful for people that cared about privacy. Okay. Now we've already touched a little bit upon this. The first question was why not just use a normal database? Is there, before blockchains existed, could you have somehow done something similar with a distributed database, somehow set it up to be write only?
Yes.
Go ahead.
Yes, you can actually absolutely do that. But strictly speaking, from a technical standpoint, traditional databases don't actually use cryptography out of the box. So when you create a system using traditional database, you lose the powers that come with your cryptography, like I mentioned in zero knowledge proofs, which provide a great deal of auditability and verification to your system. So it's just an addition to the traditional database systems with some economics incentives on top of it, so that the traditional database system it transforms into much usable system.
Okay, so somebody could potentially build a private blockchain system with this open source code for a traditional database. Okay.
Database,
Okay. So
like in case like BigchainDB, I think uses distributed database in addition with some cryptographic stuff on top of that. So that's a real world example of what we are talking about.
Okay. And so so the one innovation is that it's right. Well, I don't know if we call it an innovation, but it's right only. That's a useful property. Is there any big innovations that you can think of that we need to know when we think of private blockchains? What's novel?
Okay, there's nothing that can be termed as a groundbreaking innovation, but there are some real world problems which cannot be solved with centralized systems or public blockchain. So in order to solve these problems, you have to use private or permission blockchains. Now, as the conditions and circumstances are different in this private setups, we have to develop some new consensus algorithms, and in some cases we have to develop some new hardware. So there is some innovation, but like it's not groundbreaking.
Okay. Okay. So, when you said that you could build a private blockchain from a traditional open source database, that kind of helped me to understand. It's not really like an entirely different alien product,
Yeah.
but it's just, you can add to it to just add the new features. Okay. That makes a lot of sense. Okay. And so what about, I know people that are interested in Ethereum and Ethereum Classic have heard of Quorum, which is JP Morgan's fork of the Ethereum source code. Geth, I believe, the specific client. So can you say something about that, so people that are interested in this type of blockchain might be wondering about Quorum?
Okay, like talking specifically about Quorum, we actually have projects which use Quorum. So like I've tested a lot of platforms, but Quorum appears to be like really performant among all of them. So like in one of my articles, we published our finding that the TPS reached to 550 transactions per second, which is not reached by like any private blockchain till now. So like many blockchains publish that they actually got like hundreds of thousand TPS, but actually they are using some specialized hardware and some specific systems so that they can reach that level. But Quorum is one of the platforms that actually in practical use cases reaches some sort of good reputable TPS.
Okay. Now, so that just also shows that not every transaction on a private blockchain is voted upon, right? If you're doing thousands of transactions a second, obviously you can't have a vote for each one to approve or not approve. Okay. So one of the benefits people like of Quorum is that it's much faster. Would you say it's much faster than other private blockchain solutions?
Yeah, most of the solutions, for example, Hyperledger Fabric and Coda, it's much faster than that.
Oh, okay. So then that's a big reason why somebody might be interested in okay. Yeah, because I have sometimes people ask me, what's the difference? Why should I choose Fabric or Corda or Quorum? So that's good to know. So it's there. That is one reason.
Maybe. Yeah, we actually tested it like a year earlier, but like it seems like maybe Hyperledger Fabric is better in terms of the modularity of their code base. So like you can swap in any consensus algorithm or like any implementation that you like. So like Hyperledger Fabric is really catching on right now.
Oh, no, see, okay, that's another useful bit of information. So if you want speed, Quorum is known for speed, but Fabric is, like you just said, it's known for easy customization.
Yeah.
Right? Yeah. Okay. Is there anything good or reason why somebody would pick Corda? Just off the top of my head,
Okay. I didn't actually went too much in Corda, so.
Yeah, the attention seems to be in Fabric and Quorum.
Yeah.
So, yeah. Okay. Great. So I think we've gotten a pretty good intro and explanation of private blockchains. Is there anything that I missed or anything else that you want to add?
Maybe we can talk about the applications why private and permission blockchains are useful.
Oh, yeah. That's a great question. So, like, what are some of the applications companies? What are the use cases that they love Quorum and other private blockchains?
So there are some real-world problems which cannot be solved by either centralized systems or public blockchains. So private blockchains and permission blockchains are great fit here. So let's just take an example. If a blockchain network is used for managing dealings in a farm produce from its origin, the farm, to the end customer, for example, the market, the process involves multiple entities where permission networks may offer the best fit. Say a farmer cultivates a medicinal plant that he ships from multiple markets across the globe in distant regions. Since such transactions may involve multiple parties like country's custom department that clears the produce to enter the respective nation, shipping departments who move the product, and storage and warehouses operator who need to maintain the product within a specified temperature range. The farmer may finalize a particular price and quantity for selling his produce to a buyer, let's say in America, and another price to a quantity to another buyer, let's say in Europe. The other involved entities, like I previously mentioned, custom departments, shipping company, and warehouses operator, may not necessarily need the information about the agreed prices between the farmer and the various buyers. Uh, they may simply need the access to the limited information like quality specifications and quantity to perform their necessary functions in supporting such deals. There can also be situations in which a farmer wants to keep his transactions private so that individual buyers don't know the price at which the farmer sells the produce to other buyers. Permission blockchains allow such restricted implementation and limited permission to these various participants on such business blockchains. Uh, this can also be applied to many industries such as healthcare, agriculture, and clothing to track supply chain and logistics to ensure that our medicines, food, and clothes are safe and authentic. There's also a great room for applications in government departments uh, like land registries to provide a convenient and secure system to track our land records. We can use private blockchains for also for voting, which allow only people of respective country above a certain age to participate in the system. So if I use a public blockchain here, so like people from every country with every age group can vote. So that kind of messes the system.
Right.
Government can also use this private blockchain to show the funds allocation and spending so that people can actually see how the funds are being spent, which can actually reduce corruption in the long run.
Okay, so supply chain is a big application for private blockchains. And you also mentioned voting, and I think people could easily understand that if you have a supply chain with lots of people interacting, you may not want everybody to be paying ether, right, to submit to the public. That'd be kind of silly, right?
Yeah.
So
that's a main problem with the with the public blockchain systems, that you actually have to pay the miners to do the task for them.
Right, but with private, it would be lower cost.
Yeah.
And then also you mentioned that you could have you're right, fine-tuned custom privacy private systems. Okay, yes, very good examples. All right, so anything else? Any other comments? Any other applications you want to add to that? I think that was pretty good. That's a supply chain. I think is huge.
Huge, right? Yeah, really huge. Like because like it can be actually applied to like literally every system. Like if you go to buy like Adidas shoes, like you are actually not sure if it's actually Adidas, because like if you are buying it from the store, then you are actually sure. But like if I'm buying it from Amazon, like sometimes it comes out to be a copy. So like Amazon does provide a replacement system, but like if they actually use blockchain, they can actually reduce the cost for this reshipment and other stuff.
Right. I was just reading a headline today that the actor William Shatner of Star Trek was he partnered with a blockchain startup to fight counterfeiting of his.
Counterfeiting is like really huge market for blockchain.
Yeah, for memorabilia or toys related to Star Trek. So great
because stuff. It provides digital scarcity plus the verifiability.
Right. Okay, very good. So, so I think we've covered a good amount of material for the introduction. So thank you again. Thank you, Viva, for enlightening us and taking time out of your busy schedule. And so, yes, hopefully maybe we could have you back on a future show.
Sure.
All right. Bye-bye.
Bye.